Yo, what's up, everybody? Welcome back. Today we're working on our collaborative Rube Goldberg machine, and today's topic is running our Wasm-defined user-submitted chambers on the server. So what we have right now is, hold on, I didn't open it beforehand. I just totally forgot. One sec. We have to go to work. What we have right now is we have this example application where we have a server that's running in Zig, and he exposes this like website that you can go to that renders the current state of our Rube Goldberg machine. So if I go here, and oops, sorry, I have to check out the right version. I should have prepped this before starting. I forgot. I got distracted, trying to make sure that I wasn't getting lost. But one second. Check out Origin Master. Zig build. Okay, this is what we have right now. If I go to localhost 8000 index, we have this chamber where these platforms are defined by this plugin, we're calling them, where the plugin is the environment that will work on the balls that are controlled by the simulation. So in this chamber, we have these platforms moving back and forth. It's rendering these on the client as well as running the physics simulation on the server. Right now, we're compiling this plugin as a WebAssembly module for rendering, but we also want the plugin to be used as a WebAssembly module on the server. The reason for this is because we don't want random code running on our server, and WebAssembly is this like nice sandbox environment where we should be able to use any code that anybody's written. So the idea is that we have like, a big block of chambers, and each chamber is going to be uploaded by a user, and like ball will go in here and it'll go between chambers, and each chamber is going to perform some sort of complex actions. This is where we're at right now, and today I want to work on basically converting this plugin from a Zig module that we're just using directly right now into something that is the same module that we use on the client. Okay, so the first step, I think, is we did this like Wasm test a little bit before we started this project to make sure that we could at least like instantiate a Wasm module in a like Zig environment and interact with it in some way. But we never really tested like passing chunks of memory between them. So like the Wasm, the way the Wasm memory model works is you have like Wasm module, and you have like execution environment, which is usually the browser. In our case, it will be Zig or the browser, and you can have one chunk of memory, as the spec is right now. There's an extension for multiple chunks of memory, but let's just assume one chunk of memory. Either it is provided by the executable and like fed into here, or it is provided by here and exported to the execution environment. So if we go into our index JavaScript here, we have like an example of trying to interface with this memory. Let's see if we can find where we do this. Right, so when we instantiate our WebAssembly module, we say, hey, could we allocate some memory from here? And it will give us like a pointer, and that's a pointer is an offset into like this chunk of memory here. And so then we can like copy stuff into that memory from JavaScript and then use it from within our WebAssembly module. The other way would be that we construct this guy and we feed him in. But when we compile our WebAssembly modules by default, the default behavior that we see is that they contain the memory in here and they export it. So that's what we've been working with so far. When we did our like C WebAssembly test, Zig WebAssembly test, whatever you want to call it, we didn't try this interface, but it's going to be very important for our simulation because we're going to have like, hundreds of balls bouncing around our environment, and we need to feed them into the module so that you can like access their positions or locations, etc. So we have to figure out how to do that. Once we've done that, then we can like take our existing chamber, convert it into using that model, and then once we have it, we have to like load the chamber through Wasm in our server. We probably will want to pull out a physics library that can be used from any language, right? So the benefit of using WebAssembly here is that somebody could write their environment in C, they could write it in Zig, they could write it in whatever language they feel like, they could write it in Rust. And so we need to make sure that like any physics that we expect our modules to do is accessible from any language. So like right now, these platforms, the ball hits the platform and then bounces off. We need to make sure that that behavior is consistent between different languages and stuff and different modules. So we need to extract our physics library, and then once we've done that, we can like experiment with making a C chamber. That's kind of like the plan for today. I don't know how far we'll get because this could be like a fucking rabbit hole that we don't want to dive into, but or sorry, that will like consume a lot of time. So we'll see how far we get. We'll see how far we get. Mackie, thanks for the tier 1. Millennial, thanks for the prime. Appreciate it, you guys. Appreciate it. Okay. Okay, so before we were looking at this, last time we did this test, we used this like Wasm micro runtime. And we started by looking at these C API examples, which is this like specification from the WebAssembly guys that basically says, hey, no matter what WebAssembly engine you're using, you can use this Wasm C API and it will work on any engine. Now, this was like poorly documented, and it still is poorly documented, but we understand it a little bit better now, where they have like a little bit of documentation in this repo, not a lot. But they do have some examples that maybe we can pull from if we end up using this. However, what we ended up doing eventually on our test last time was we ended up just avoiding that thing altogether, and we ended up using, let's see if I can find it, this other interface, wasm export.h, where in here we could do, let's see if we have our example somewhere. We must have it. It would be here, yeah. So we could just say, hey, you load this module from this data, and then instantiate it, create some execution environment, and then I would like to look up this function, please, and then I can just call that function. That was pretty straightforward. But I was looking today just before stream, I kind of assumed that there would be a similar interface for getting memory, but I actually didn't see that anywhere in there. So that's probably where we have to start, is figuring out, using this like this interface, can we extract a memory segment or not, right? So that's what I was looking for before stream, and then I didn't find it in time. They do have this concept of like Wasm runtime malloc, but this feels like their execution model is like the other way, right? When we were talking about either the module defines its memory or the execution environment defines memory, like seeing this thing like Wasm runtime malloc, it seems like this would have to define the memory, or else we don't know how to malloc, right? The malloc has to be owned by whoever owns the memory. So that's my guess here. We'll have to take a look at that in a second. I was kind of hoping that there was some way to like extract exports from this guy. So there's like this like get export count, and we can like ask for export types. And it looks like it could be either a function or a global. Import export kind. Oh, here. So they do have like a memory export that we can access, which seems reasonable. But I don't know if we can like get at it in any way. So I'm assuming globals are like just like variables that are exported through some mechanism. Memory are like what we actually want. Table, I think, is for, I remember seeing that this is for like indirect function calls, I think. Don't quite remember. And then function is just a function. So it's interesting to me that when you walk the exports here, that there isn't data for the memory. But maybe it's because like there isn't like extra info that's associated with it. I wonder if there's some way to. Okay, so when we look at our exports, we can basically walk the export list until we find one that is of type memory. Can we do anything with that? Can we do anything with that? We can get the export type. Export. Get export global instance. How are we running functions here? It's like wasm runtime function. function, lookup function. Yeah, none of these really feel like what I want. So I'm concerned that maybe this isn't a possibility with this API. Let's just quickly take a glance at whatever this is. What is this lib export header? This is not useful. Okay. But maybe we can look for usages of this Wasm import export kind memory, and maybe that will give us a clue. So maybe they have like examples somewhere where we can look at that. So it was Wasm import. Wait, no. Is that really not right? Build, install, include. It was memory. Yeah, Wasm import export kind memory. So can we maybe just look for like Wasm import export kind memory? Ah, fuck me. Okay. So this is a really bad sign. Yeah, so they just don't support this. Shit. Okay. So maybe this is just not the library for us. We could look at other Wasm runtimes. Other Wasm runtimes. I think that the ones I've seen are, I've seen wasmtime, I've seen wasmer. How do we like popular Wasm runtime? How do you find a library? Because I found this one that we were looking at before by just googling like Wasm runtime C because I wanted to be able to use it from Zig. Maybe we can look at a Zig Wasm runtime. Somebody will have made maybe bindings to Wasm runtime binding to the normal C API. So this is going to have interop with anything that has Wasm C API, such as Wasmer or wasmtime, that kind of lines up with things I've seen before. What does this look like, actually? Let's just see how nice this would be to use. Does look kind of nice. Kind of nice. But it also seems like they're not wrapping a whole lot of code. So maybe we will have to fall back on the Wasm C API for someone else. Let's also see. Okay, let's look at Wasmer and use Wasmer from C. Is that like possible? It looks like they only export through that Wasm C API, which was a pain in the ass when we started looking at it last time, but maybe it's our only option. Use wasmtime from C. C API lines in the Wasm repository. Wasm.h. Wasm C API. Okay. Here we go. Full C API documentation can be found here. Okay, yep, you make an engine and a store. Okay, so it looks like these are using both Wasmer and wasmtime are using the like normal or the like the common Wasm C API, which we hated last time we tried it. But maybe we don't have a choice. Maybe we don't have a choice. Which sucks. Which kind of sucks, but we'll have to live. Okay. Let's maybe start by trying to call a function using our existing chamber interface. So we have a WebAssembly module. And maybe let's just try to call its like alloc function, which says like, hey, could you give us a pointer to some memory? And then I guess we need to use it in some way. But we'll get there. We'll get there. Okay. Gross. Gross, gross, gross. Okay, so I think I saw Wasmer export memory. I think I saw this when I was Googling this earlier. So they, at the very least, have an example that supports taking some exported memory from within a Wasm module, right? Here's their thing. They have export memory, and they have some sort of example of working with it. So at the very least, we know that the Rust API supports this, and then we're going to hope that the C API also supports this. Okay, let's figure out how to build this thing. Wasmer C API example. Wait, was Wasmer the one we wanted, or was Wasm? I also wanted to look at wasmtime maybe, and just see wasmtime export memory. Let's see if they have an example. Okay, here we go. So this is, oh, this is exactly what we want. This is like almost exactly what we want. Okay, so we just have to flip a coin. This example already is written in C, which helps us a lot. So maybe let's start here. We'll pull in wasmtime. Wasmtime. I don't want to just fucking do this. Give me. They have a CMake package. Can I just like build it from source? Can I just build it from source? Because I don't really want to like pull in CMake complexity. It does need to be compiled from Rust. And surely, I guess we can look at their CMake example and just kind of copy it. So how do they fucking compile this thing? Come on, man. Cargo. Oh, so it's just a create C API that's like in here already. Ah, here we go. So this guy probably depends on wasmtime. Nice. Okay, perfect. Okay, so we just compile this crate, probably. Who is going to hopefully create some sort of shared object that we can link against. I guess we can just try it and see. What the fuck? Why did it say 14? Git, clone, paste. There we go. I don't know where the fuck that 14 came from. Give him a sec. He's got to think. Receive objects from the internet. Okay. So let's see. So we think there's a crate in here that we can just compile. Wasm C API, cargo build. We don't have cargo. So that's the first thing we have to fix. Cargo. Rust up. That probably makes more sense. Dun dun bump bump bump. Bump 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 bump. Okay. So what did we just? It was wasmtime. Where the fuck did I clone it? Oh, I cloned it here, which is stupid, but whatever, we'll live. CPI, okay. Cargo built. Okay, nothing's crashing or anything. Looks like we don't have to like upgrade our Rust versions or anything. We'll see in a second though. Maybe we're getting a little too far ahead of ourselves. Okay, what does he give me? Where is my output? Target, debug, C API. That's not what I want. Okay. What else do they do here? So libwasmtime.so comes from somewhere. They call wasmtime cargo binary build target wasmtime target from this wasmtime crate. Where does it come from? Where? Maybe we just build up here and look for a shared object somewhere in the middle. One of these things must. We could maybe look for crate type. How do you like Rust export shared object? I think there's like this like dilib. Is Wasm on the server a good idea? Won't that cause unnecessary overhead? It will cause some overhead, but not as much as other scripting languages, I would think. And I think I don't really have a choice if I want user-defined chambers. I think. I could be wrong there, but I think that like we have to do some sort of like sandbox execution environment, and Wasm seems like the best option. Because at the very least, from my like performance test that I've done before, at the very least, Wasm is like reasonably close to native performance in my experience. But maybe not. How do I say this? It's not like perfect, but it's a lot better than like scripting languages, at least as far as I could tell. Okay. Is this guy gonna finish building or what? I think, okay, we want to see which crate contributes the C API. So we can do some sort of like, uh-oh. Is everything okay? Why can't I quit? Oh, disk is getting slammed probably. Stream seems okay though, so we're chilling. We're chilling. Can we like grep find all cargo tomls? And then can we do like grep dilib or some things? We want to do xargs grep dilib. There we go. Okay, so these are the guys that export shared objects. So it looks like C API is what I want. What did I build last time? Cargo build. Oops. Crates. Dude, why is my fucking disk got slammed? Look, it's just like not fucking LSing. Fuck off. Crates C API. Cargo build. Like, what is happening? Oh! The whole point of us doing that WebAssembly test before all of this was to make this easier. But it turns out that we didn't get quite far enough in our tests, and now we have to deal with this shit. Okay. Do we see... Where is like the output of this thing go? Artifact? No. Oh, but then maybe this is what I want. Cargo build here, maybe? Aha! Ha 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 ha. There it is. Give him a sec. Building, 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 building. Oh boy. Oh boy. Oh boy. Oh boy. This is doing stuff, right? Like this is compiled right now? Okay. Okay. There we go. Okay, finished. What did it make? Target? Debug? Ah, here we go. libwasmtime.a. Good sign. Good sign. Now we have to probably... We need to get like the header from somewhere. But we can maybe go back to this example here. Let's just kind of copy paste this whole example somewhere and see if it compiles. So we can do something like delete this, who cares about this? Paste this shit in here. And this is including wasm.h and wasmtime.h, which must come from somewhere. Here. Perfect. So we should just be able to go gcc-o test, compile test.c, including wasmtime, c API creates, wasmtime creates c API include, and -l wasmtime target debug, -l wasmtime. No wasmtime conf.h. So where does that come from? Where does that come from? Is it in, maybe it goes to the target output? No. Fine. Can we fucking just read some, here, maybe we should follow their documents. Cargo build release -p wasmtime c API. Then they compile this using creates c API include. This is essentially what we did, right? But they don't have wasm, they don't have that conf.h. But this is close. Maybe we should start with the hello world. Let's start simple and then build our way up. Okay. So fuck whatever we do. Oh no. Yeah, we'll start with hello.c. We will. Rust says CFFI. How does memory management work? I mean, you can just here, hold. If you did like a test Rust, you can just do like function. How do you write Rust again? It's been a second. Alloc, and you can like alloc some memory. Mem is a U size. I think it's like this, and you can return like a const u8, or I guess not a const u8, and you can just do like box new, something of that size. I think you do like vec 0 of mem size, and then you can do like into boxed slice, and then just leak, right? So you can like use Rust's heap allocation, and then just like lose memory, and then return that memory back to C. But that's just like one of the many memory models you could do. You don't have to do that one. Okay. So they're saying I go into here and I run this cargo build, which is very similar to what I ran. I just went into the crate directory itself. And then they're saying I can compile with my GCC with just this thing. So GCC using wasmtime creates CAPI include with this library. And I also need LDL LM LP thread. But there's no, where wasmtime conf.h not found. So find wasmtime -iname conf.h. That's nowhere to be seen. Maybe I need to run this exact build command, which isn't what I ran. Fuck release mode. I just want to make sure. Yeah, that's all there. So why is conf.h missing? Where is that supposed to come from? Wasmtime conf.h not found. Okay. What the fuck? Yeah, so this is supposed to get compiled out to somewhere, right? They have this conf h in, and this is supposed to get like exported in some way, shape, or form. But it's clearly not. Who is responsible for this? It does look like this CMake thing is responsible for it, which is funny because this example doesn't talk about CMake at all. Oh my god. Okay. It's fine. It's fine. We can make it work. We can make it work. Fuck me. So surely if we run cmake in here, it'll do something sane, right? Okay, there we go. Running cmake here did create conf.h, which doesn't feel like what I was supposed to do. But maybe it's fine. Fuck it. Fuck it. Okay, this compiles. At least we have this example. And let's take this hello world thing and compile it. Okay. And now we should be able to run whatever the fuck this is. Right, so he's mad because lib wasmtime doesn't exist. Can we like force it to be static? If I just go like, can you force gcc force static link? Use -l colon instead of -l. For example, colon.a. Okay. They're saying if I do this, no wasmtime.a, they wrote, oh, lib ... .a. So if I write lib wasmtime.a, okay. Cool. So that compiles, and we can say test with hello what? Or hello wasm. Okay, he doesn't like this. File results. Maybe we read the fucking file. Maybe we read what we're fucking doing. So where is this file is null? He's looking for examples hello what, so we just say we'll use /hello what instead. Run this thing again. The static linking actually takes fucking forever. Holy. Okay, there we go. So this example works, which is a good sign. And we can look at what the fuck are they doing here. Geez, this is crazy. So they create an engine, they create a store, then they compile the module. Okay. All of this is like compiling the module. Then they compile it here. Yes, module new. So here they turn the WebAssembly text format into a WebAssembly non-text format. Here they load the module into the engine. But then from there, okay, what is like the store for again? Nobody really uses it directly. Just a long-lived group of Wasm modules. Okay. So then in their case, they look for the function run, and they call this function from this extern thing. Okay. So they say, hey, this thing is a function. Can you please call it? Okay, that's actually not that bad. That's not that bad. Let's look at their memory example. And then we can try to adapt their memory example to something that we have written from Zig. Yeah, it's fine. I don't give a fuck about this. Okay. Then we'll copy their thing here. This, we're gonna have to probably fix some sort of fucking import thing. Where do they like get the file from? Here, this comes from, we call this hello what, okay? And let's see if this thing works. Bump. Can I bundle the Wasm runtime in an image like in common Lisp? Can the image then be stripped? I don't know what that means. By image, do you mean like a PNG or like a container image? Like, what do you mean by image there? Like a disk image? I think that like that word's overloaded, so it's hard to understand. And what do you mean like in common Lisp? I'm not a Lisp guy, so I don't really know. I don't know anything. You can tell I'm really fucking lost, actually. Okay. Okay, so this guy, he's going to be very similar to the hello version. He creates his module. And what is a wasmtime instance? This feels new to me. Okay, but we'll come back to that. Here, I see. So he need to interact with the memory stuff. It looks like we need like wasmtime specific calls. Did I forget to call wat to wasm? It's actually fine because they are using their own wat to wasm compiler inside in their example. So I intentionally skipped that part. Okay. So how do they call their function? Missed the beginning. Why are we switching from wasmer to wasmtime? We were never using wasmer. We were using wasm micro runtime was our initial thing. This is what we tried before, which is like a C implementation. And we switched because we couldn't find a way to view wasm exported memory from this thing. It looked like it wasn't supported. When we looked at the source code, we found like a export memory unsupported assert 0 type shit. So I just started looking at wasmer and wasmtime, and wasmtime has at least this example of using exported memory from a module, which is exactly what we want. And it's from C, so C to Zig translation will be reasonably easy. So I think that we can just kind of start here and see what happens. Okay, so it looks like there's a lot of code in here. To kind of like do some assertions and stuff that we don't actually need. None of this really matters. We only really care about probably this. Yeah. This feels good. So this is them being like, okay, so we got this memory that was exported. Can we look at like its initial data? And like, how do they actually work with this thing? Wasmtime memory size. Okay. And wasmtime memory data size. How do they like get data out of the wasm memory? Mutating memory. So they call wasmtime memory data. I see, and this just pulls out a pointer probably. Wasmtime memory data. Where is this defined? Oh, perfect. Perfect. Okay. Yeah, this makes a lot of sense. This makes a lot of sense. So it looks like maybe like the wasmc API isn't like advanced enough. Can we look at that hello world.c again? Did I misread this? Is this all using wasmtime stuff directly? Oh, it is. Instead of the... Yeah, it's fine though. I don't really care. Because when we tried the WasmAssembly C API before, it was like clunky as fuck. So I'd way rather start with something that's just like finished and has like full examples here, and then we can always wrap it later if we want to change to something else. Okay. So let's try to adapt this example to load one of like something that we write. So we're there right now. They have a WebAssembly module that's exporting some memory, and they have a function called size and a function called load and a function called store. And all they're doing is putting stuff in there. Let's do something like we can write a test zig that does like export function. How do we want to do this? Let's just copy our allocator function from here. Or is there like a hello world we can write? Maybe that makes most sense. Yeah, let's do that. So I think we had probably in our test at some point in here, we must have had a little hello world that we wrote somewhere. But it's not really easily accessible. It's okay. Okay, here's what we'll do. We will write a function that returns some memory with the data hello world in it. We will load that from JavaScript because we know how that API works and just try to make sure that that's correct. Then we will try to load it from C and make sure that we see the same behavior. Seems reasonable to me. So we can do like test zig. In here, we're going to say pub export function get string. And he's going to return a pointer like this. Maybe a null terminated string. We are going to say that that null terminated string is hello world. Simple so far. Super simple so far. We should be able to export this thing as a WebAssembly module. And we should be able to look at this thing by just doing wasm to what test.zig. Wow. Oh, oops, test dot, sorry, what did I compile this thing as? Test.wasm, probably? So here we have our function get string. We have our export memory. Our function get string is function 0 here, and he returns a constant value of this number, which is stored in the memory by this flag with a null terminated string. Perfect. Now, maybe what makes sense is we'll write a little test HTML. And he will load a test JavaScript. But first, let's just make sure that we know how to write HTML. So say hello, smile. And then here we'll say script is equal to source test JavaScript. Yep. Okay. We know that we have to run an HTTP server here because you can't load WebAssembly without it. And so now if we go localhost 8000 test HTML, we see hello smiley face. That's good. And in our console, we see nothing, but we can do like console log hello world here as well. Refresh, hello world. Okay. Good initial state. So now let's load our WebAssembly module. So this comes from, can we do like window onload is equal to init and shove all this in an init function just because I'm not sure. Async function init. This goes here. And in here, we're going to fetch test wasm, no imports. And we are going to try to look at the function get string. So this is the string pointer. And we are going to try to look at the memory in the WebAssembly memory. So this should be, why the fuck is my like indent wrong here? That's fucking annoying. It's fine. Obj.instance exports memory buffer. And we're gonna look at the, I guess we do uint 8 array. I think this is how you're supposed to do this. So we look at here, and we take the offset of, yeah, we'll just take the whole WebAssembly memory, and then we can look at array string pointer for some amount of bytes. We can say let const var I equals 0. No, let. We want let. Local scope. I remember JavaScript. And we can say, while true, we're going to look at array plus I. Yes. And if v is equal to 0, we break. Otherwise, we console log v. Or maybe we'll say we have some string. And we can say like s plus equals v. And then at the end, console log s. So that should give us something that prints out our hello world if we did everything right, which we probably didn't, but we can dream. Yeah, nothing fucking happened, but can we say at the very least console log I? At the very least, does that do something? Refresh. Nothing happening there either. Console log hello. Nothing there either. Why? Just is init being called at all? Enter. Test HTML. Oh, that while true is probably just never escaping. Because I never increment I. So it's probably just hanging everything. Oops. Browser does not like that. Yeah, he's fucking frozen. Okay. Let's cap this loop. At 100 or something. There we go. Okay. Okay. There we go. Our JavaScript's running at the very least. So, can we look at each index, what do we get? I think that makes sense. So, do we see HELLO space WORLD? That looks good. We see a 0 at byte 11. So I think that we're probably seeing the correct thing here, and it's just the string manipulation is just wrong here. So we have to do like what? I think it's like let const encoder is equal to new text. No, decoder. We want decoder. And then you do like dec decode array slice string pointer to string pointer plus I or something. And then console log s, and then fuck this shit, fuck this shit. Does that do what I want? There we go. Okay. Good sign. So we're seeing hello world log from JavaScript, which is getting a string from our WebAssembly module. And then just to make sure that we're, doing what we think we're doing, we're going to say like hello from Zig instead of hello world. And we can say wasm to wat or wat to wasm. We compile this thing. No, Zig build exe. That compiles this thing. And when we run this thing again, we should see, fuck. It says hello world still. Fuck. Why? This says hello from Zig in test.wasm. Test.js is fetching test.wasm. So what the fuck? Where is this hello world coming from? Is it like something? Oh yeah, here we go. Hello from Zig. There we go. Okay. Okay, so we have a WebAssembly module that is exporting some memory. We can look at that memory from JavaScript, which means that we understand the memory layout of our WebAssembly module. Huzzah. And now we can get back into the C stuff. And let's see if we can do the same thing from C. So we want to probably skip this wat to wasm stuff. Okay, let's try to like we want to limit the change from their example just to get us going. So maybe what makes sense is initially we'll take our compiled test.wasm and we'll do wasm to wat, we'll inverse it and put it in hello wat, because I think that's the file we were using in the test C file. So now if we run our test C file, it's going to say, hey, I didn't see the functions exported that I expected to be exported, but that's okay because we've changed the interface. So what we want to look for is we want to look for get string as a function, and that's going to be shoved into item. And then I guess we will just return here. So we'll recompile. Wait a year for it to finish linking against lib wasmtime.a. And now this doesn't fail, which is good. And if we wrote like get strings plural, we should see our assertion come back. Okay, yes. So we have found our function get string. We have also found our memory section. That's very good. Let's kind of discard. I guess we don't need any of this stuff. All we have to do here is we want to look at the memory, which just comes from wasmtime memory data. And we should just be able to say, go here, plus, well, we need to call the function getString. So how do we call a function here from here? How big is the test binary? Holy fuck. Wait, hold on. That's a good eye. Let's strip our wasmtime.a of debug info at the very least. What strip lib wasmtime.a. Holy shit. Okay, is that better? Now he's down to 206 megs, which is better, but that's probably still not going to be great. But let's try building it again, just to see. Because I'm curious now. 1 Mississippi, 2 Mississippi. That's a lot faster. I'll take it. Okay. So how do we call a function? Let's look at their... is there something in here? Check call, load func. Right, so in their thing before, they had a function here. How did they get it? Size func is here, and then I think they said, like, so here we'll make our function. We'll say get string func, and it looks like you just do get s func is equal to item of function, I think. What header is this coming from? This is coming from wasmtime.h. Well, let's look at maybe their example here. Yeah, item of func. So not function, func. And then we should just be able to call this thing in some way, shape, or form. So check call 0. So they just call check call, which is they have some function, they have some wasmtime val args and args. So here they call wasmtime func call. This is really what we want here. And we want to call our get s func. Where does this store come from? This is just context, I think. Wasmtime context t is store, so context equals, yeah, okay. So this is the context, this is the function. We need to pass in our args. How do they create args? They create a array of wasmtime val t. But our array is going to be empty. So can we just call, maybe this is null, and args 0, and then here we need to get some results. So how do they get results? Their results, what the fuck? Oh, here, it's just one expected result. So we can say wasmtime val t results 1. We can pass this in here. And what is this trap? Wasm trap t. I don't know. but we will pass it in, I guess, because they want it. And so at the end of this, we should see that we have our pointer in results 0 of I32. So we can just see what we got here. We can say printf response is this thing. Okay. And let's run this. Fuck! It's because it's called get sfunc. Fine. If you want to be like that, fine. We'll use the words we read. Fuck you, C compiler. Redefinition of trap. Interesting. Redefinition of error. Also interesting. Fine. We'll call this func error. Just to get him to shut the fuck up. Incompatible type expect of wasmtime func call. What did he expect? He expected a pointer. So we just put a little ampersand here, I guess. Oopsies, did I hit save? I'm not sure I did. I did not. Okay. So this, we get our response at 104.8576, which if I remember correctly, if we did wasm to what of test wasm, we see that same number here. So that's a really good sign. We've called this function that we exported, and we find its offset into memory. So now all we should have to do is we should just be able to do printf this thing at wasmtime memory data context memory plus this thing. Maybe. Hell yes, baby. Let's fucking go. Okay. So we have an example of interfacing with memory now, which is sick. Super sick. Super fucking sick. And I assume that mutating memory, all they do is they just change the stuff in the pointer. So it's super easy. Super easy. Okay. I think... Fun fact, you can switch to a different tab, no need to just constantly suspend nvim. Hey man, you can't stop me. I'm a fan of doing it that way. I don't know why. It just feels nice to me. Just feels nicer. Okay. So I think that this is actually, like, looking at what actually is being done here, this is really actually not that bad. Not that bad at all. They create an engine, a store, a context. Here, we should change this to load the wasm directly. So let's see if we can adapt it that way. So here we should just be able to pull all of the contents of the file into some buffer and then call wasmtime module new on that buffer. So let's look at, this is going to be test wasm. Well, okay, first of all, copy test.c test C back because we're going to fuck something up to the point where we can't recover. And here we're going to do, let's open test wasm. We're going to get the file size and read. What does this do? Just reads into this vector? Sure, so we'll do that. We won't do this. Oh, it seems like we can just probably get away with doing this. What data wet size? Because this is pulled into this stuff here that they called wet. So this should just do the same thing that it used to do. He doesn't like that because error undeclared. Fine. So we'll kind of put this here so that it is declared. Delete this shit. And then where here it says binary, we say what? What? He just still doesn't like that because here we need to delete this thing. Okay, there we go. He's doing the same thing. So we're chilling. We're chilling. Let's make a Zig module that will load a Wasm module. Yeah, sure. So we'll call this like Wasm chamber in all caps with camel case. Wasm chamber. This channel is fun even though I barely understand anything. Hey man, that's kind of cool. I like to hear that. I apologize today especially. I'm just kind of like ripping through stuff, not explaining very well because I'm lost as well. So hopefully you don't feel like this all the time. Did you ever look at the Zig Wasm runtime Z-ware? Maybe mature, but like these smaller binaries. I think that I don't want to make my life more complicated by pulling in a like low usage Wasm runtime, you know? Like maybe it's worth looking at in the future, but I'd prefer to start with something that I know will work, like wasmtime, and then work my way back if we want to later. Right? Like that maybe immature is like really would be very painful to me at this point in time, if that makes sense. Okay. So the real question is whether you've considered making your own Wasm runtime. I think that will be fun and is something that I have on my to-do list of something that I think would be a fun little project, as well as making a compiler that compiles Watt. I think both of those would be pretty fun, but I think that's far out of scope. I think that if we did that in this project, we'd never finish this project. You know? You know? Okay. So this guy is going to have to maybe include, or C, we'll call it, is a C import section where he's going to C include Wasm, what is it called? Wasm.h and wasmtime.h. And he is going to store these things. So this goes like this. Engine, we have s engine store, and then we have s store context. Okay. These things are not going to be instantiated right now. Okay. And then when we initialize this guy, he is going to create a Wasm chamber. And he's going to need to be initialized with some path where we are getting the module from. And we will start here. Let's just see if we can call these functions and create this thing. And if we can, we are in a good starting point. So we'll say here, the engine is this, the store is this, and the context is this. Boom, boom, chilling, and then we just return engine is equal to engine, store, context, boom. And then what we'll do here is we'll do pub function main. We'll just shove a main file in here so that we can kind of work with this file directly without worrying about everything else for now. And here we should just be able to do like const chamber is equal to wasm chamber init with our test wasm. All right. This needs to be from C. And for now, we also discard the path. It's Wasm engine, but Wasm time store and Wasm time context. Yeah, that's interesting. I wonder why. That is kind of odd. You're right. You are right that is odd. But I think that we're going to be short on time today, so I'm not going to think about it. Not thinking is... Oh, for the types that are wrong. Oh, good eye. We would have discovered this in a second, but you beat me to it. So we should be able to run zig run source wasm chamber zig, and it's going to be like, what the fuck? I don't know where those things are. And so we can say include. Basically, we're going to pull in a bunch of these compiler arguments that we used in GCC. Right? So can we just do this? He's not going to find lib wasmtime, but maybe if we do like this, he will be happy. Okay. A lot closer. He doesn't like that this engine type is... Okay, yeah, these need to error out, so... or else... Return... Error initialization failure. I don't know, it doesn't fucking matter. Same here. This guy gets the same treatment. This guy gets the same treatment. Uh-huh. Then here we have to write try, and this has to return failure as well. Chillin'. Big chillin'. Okay, so now we have to open the file and read it into a buffer somewhere. So we're going to say stud fs, no stud, const stud is equal to import stud. Import this stud, baby. Okay, current working directory, open file, and the file is the path. And then we need to read this thing, so f.read all into some buffer. And we just read to end alloc, nice, with some allocator. So I don't want to think about file sizes because I'm a lazy piece of shit. And I think it was, were there options in there? What was this read to end alloc? Allocator max bytes. So I guess I still do actually need to think about it, but we'll just say like 1,000,000. A billion? A gigabyte? Let's say a megabyte is a reasonable max size. Fuck you, Zig, for making me think about things that I need to think about, you know? What an asshole. So here this is const data is equal, or wasm data is equal to this. We need some allocator now, so we'll take in our allocator. Which means that we have to say const allocator is equal to allocator is equal to stud mem allocator. I spelled it wrong. Allocator, like this. Boom. Which means that here we need some const GPA is equal to stud heap general purpose allocator. Initialized default. Defer dinit. And const alloc is equal to GPA allocator. Boom, boom, boom. Chilling. I guess here we need to free this data. And then we can try to compile it. So this is just here. We call wasmtime module new. Const compile error is this, or no, error, fuck it, doesn't really matter. This is C wasmtime module new, and here we can just use our wasm data pointer and wasm data len. We actually don't have our module thing. Where did that come from? Module. Right here. Boom. So this is a this. Const module, var module, I guess. And he is initialized to null, which means that he's an optional thing. And then we pass this in here. This comes from CLand. There we go. And then in their test, or in our test, I should say, we check if error. Right. So error here is a pointer, I think, and say if error is not equal to null, we return error init failure. And we won't bother with actually logging the error because we're lazy. And hopefully this all works out. So maybe we will store the module as well. Wasm time module t. And here we'll just say module is equal to module. Does this run still? We fucked up something. Because this needs to also say, we'll call this module opt. It's an optional module. This might not end up being a full-on module, and then we can just say here, const module is equal to module, or else we return init failure. Womp womp. And this is actually supposed to be module opt. There we go. You can make it undefined at start, maybe not nullable. I don't know how this works when you pass in by pointer to a C API. The C API is expecting a nullable thing, so I don't really know if I can do that. You know? Because like the C API is using a pointer that may be null, and Zig's pointer semantics are that null is not allowed. So we have to make it nullable to represent the zero case. It looks like that still works. So now we instantiate the module, which requires an instance. Okay. wasmtime instance t. And then here we'll just say this is variable now, and this is error is equal to C wasmtime instance new. This guy takes in null instead of count null in all caps. We need to make our instance like this. So this is maybe this thing. Oh, except that this is not true. This is this. Yes, just equal undefined. Boom. We also need this trap thing. I don't know what a trap is, but it looks important. Wasm trap t. Like this. Okay. Chilling. Oh, interesting. So at this point, after they create the instance, they delete the module. So we should actually up here. We don't have to store the module. We just have to store the instance. And here we will just defer C wasmtime module delete module opt. And here we don't actually have to unwrap the optional thing ever because we're not storing it anymore. So we can just kind of use it as is here. Boom. Cool. Cool. So then we should have an instance. And we should need to check if error is null and trap is null. And this is error here. This needs to be or. Here we go. And then we return an init failure. He doesn't like this because my instance is constant, which would be variable. And he doesn't like that my trap is also constant, which should be variable. Makes sense. Now we need to export the instance. Chillin. This is not a pointer, which is fair. Chilling. Okay, now we need to extract our memory and our function called getString, which is simple. Which we are going to store over here. So this is C wasmtime memory t, and our. Let's think about this. Yeah, it makes sense for us to validate our functions now. Get string function. Yeah. Sure. So we will find these things by doing. We have like some memory. We have a function. This goes to the end of the word and gets set to undefined. And the same treatment gets given here. Okay. We pull out the memory like this. So we'll just do if call this, yeah, it's fine. Var, okay, it was false. These come from CLand, and this also comes from CLand. We try to look for memory from our instance. We don't have to, I guess we'll say const memory key is memory. And then we could just pass in memory key pointer and memory key line here. And then we need to get item from somewhere. What the fuck is item? Oh, an extern thing. Okay. Yep. Ah, I see. And then if, then we need to check that this is indeed some memory. To say if the item kind is not equal to wasmtime extern memory, we have a fucking problem. Or if this didn't succeed. Which variable declaration do you like more? C style, int name, or zig, rust all thing, const var name. I think I like the rust zig way better for now. But I think it doesn't really matter. It's just like a familiarity thing. I'm not really convinced that there's any difference. I think the only difference that I can think of is that there's probably a simplicity in compiler parsing would be my guess. I don't know if I really care. I like the idea, I guess, that you don't have to specify the type. I've always been a fan of type inference. I know that a lot of people disagree with that. A lot of people that I've worked with say, no, I need to know the types. But I've always argued that usually you shouldn't care. You usually want type propagation. And if you care, then you can always check. But I can see the other argument where you're like, I just want to review this code and I want to know that that's a float. And it's like, that's reasonable as well. Even though I prefer the other way. Okay, so if this thing is memory, we can say that our memory here is just const memory is equal to item of memory. And then we are going to do something similar for the function. Type inference is my preference mainly because I'm a lazy and it saves me having to type more. Yeah, I'm against, I guess if it was just typing, I wouldn't really care that much. But for me, I feel like, which this could be wrong, I feel like it prevents bugs in some way, right? If you have like int x is equal to 4, int y is equal to x, and then you change the type of x to a float, now all of a sudden you have like integer truncation. And if these things are right next to each other, it's very obvious. But if they get like kind of far away from each other, you might not notice. Where I like the idea that like when you do this, when you change the type of x, y automatically propagates. And if you combine this with like, I guess it's less of a problem in Zig. But in C, you don't have the luxury in every code base of having errors on like type change. So it's just kind of nice to limit where that can like fuck you. It still isn't like, it's still not perfect, right? Because you call like fy and this function expects it to be an int, you'll still get the truncation, but at the very least you don't get it on the propagation here. But I think overall it probably doesn't matter at all, to be honest. Okay. We have to do the same thing where we try to pull out the function. So we just do this again. But we look for the get s func key is equal to get string. And then we just do the same thing here. Get s func key and get s func key len. This goes into an item. We check that this is a function this time, not memory. And if it is, we are chilling. And we just say we have some function that is item of func. And then we have get string function is equal to get s func. Chillin'. Oops, this has to come up here. This item of memory has to come in here. Okay. Okay, so does this still run? Probably not. Doesn't compile. Because he expects this shit, he got that shit, so I guess this guy is supposed to not have an ampersand in front of him. Let's try that. That's fine. Wast time doesn't exist. That's also fine. I should write wasm time because we're using wasm time. Hope you don't mind the question. What do you do for a living? Robo's like belly dancer. Yeah, I'm actually really, really uncoordinated. I'd be an awful belly dancer. But programming. Yeah, I don't know. I'm taking a break right now, but I used to work at a company that did like camera firmware in like C, C++, Linux, user space application plus some drivers. That was pretty fun. I worked at this company that did like neural network stuff for trying to identify locations of 3D of objects in like a box and then like pick up those objects in 3D space with a robot and place them somewhere precisely. Also very fun. But you know, doing work for other people is always comes with stuff that you don't want to do. And so I'm like, I could take a break and just do what I do want to do, which is this apparently. Because like I like coding, but there's a lot of stuff that comes with like jobs. Like your code has to compile and like it has to pass tests and not seg fault. And it's like, fine, like I get it, but I don't want to. So we're doing this for a bit. Eventually I'll run out of money and I'll have to work a job again. But for now, we're having a lot of fun doing this. What is this zig run is what we're doing. And this still doesn't crash, which is a really good sign. So now let's maybe say, can we get the string as like a variable, as like a thing that wraps the wasm function? So we can call like self is a wasm chamber. And this should return some const u8 data. Successfully compiling is very optional here. Yeah. We do not care if nothing works. And so we should be able to do something that's very similar to what we did down here, where we call this wasm function to using this like pointer that we've stored internally. So we should be able to do like var results is equal to is like a wasm time val t that is undefined. We say, hey, we're going to call this function given our context as well as our function pointer, which is I think get string function. We're going to put null and 0. We don't know what these things are, but we also don't really care. We're going to pass in a result as a thing, and we need a trap as well. I don't know what a trap is. I wonder how many times I can say I don't know what a trap is, but I don't. So I'll say trap is one of these things, and he starts as undefined. Then we do our classic check that this didn't error or trap. If error is not equal null or trap is not equal null. So maybe, oopsies, what the fuck did I just do? So maybe we do this here. So if error is not equal null or trap is not equal null, we have a fucking problem. Internal error. And this means that this can fail. But if it did work, then we should be able to look at the result and we should be able to call this essentially. So we're going to say const p is the pointer to the memory at this location. So self context, self memory. And then we're going to return p from result of I32. I guess we call it offset. And we will cast this into a usize, because I think we have to. And which maybe this thing could return like a negative number or something. So we should maybe do std math cast into a usize. And if this fails, We return internal error. Okay. And do we have the length of this thing? I guess we're assuming it's null terminated. So we have stood mem len, I think, is a function that exists, and we can just call this on p plus offs. There we go. And then we should just be able to turn p plus offs, or p from offs to offs plus len. Boom. And then we should be able to say stood debug print chamber get string. Right? Who knows if this will work, but it's possible. He's mad because I just left some fucking garbage at the end of a line and didn't notice. So fuck that noise. He found this thing, so this thing needs to be variable var chamber. Oh, fuck yes, baby. Let's fucking go, baby. That's pretty sick. So API-wise, this is really clean now, right? So we've kind of handled all of this like Wasm pointer shit in like our initialization. We store a like function, whatever the fuck this thing is, right? We don't really know how the like WebAssembly engine is representing this stuff, but we know we have some sort of like reference to memory and reference to a string, or to our function, right? And so we just wrap that function with something that returns a pointer in Zigland, and this isn't too bad. Like this initialization stuff is a pain in the ass, but this is fine. And so being able to just like load some WebAssembly module and call a function on it, that's mwah. Beautiful. Beautiful, beautiful, beautiful. So we'll call this read Wasm memory from Zig, and we'll call that done. And now we want to do something else. What's like the next thing? We're gonna start working towards loading real chamber. I think that's the thing to do here. So we understand how to call functions, we understand how to interact with memory, and so now it's just about calling the right functions with the right memory. Seems reasonable. Seems reasonable. So can we maybe look at chamber Zig, and let's just see if we can just initialize this guy. Let's just kind of like start working through the workflow. So we're going to initialize him. Then we are going to try to step him with some balls even. And right now, these balls don't exist, or this function in like Wasm land doesn't exist. So, but let's just start by trying to initialize him, and then maybe we'll call this log state function too, because I think that would be kind of interesting. Because we haven't figured out how to like feed in functions externally yet, so we should do that so that we can have some sort of like error reporting from within our module. Okay. So we have chamber Wasm already somewhere. We just need to make sure that we're like following the thing. So we have an init function, I think. So let's call this init function, and let's just start there. And then what was the other one? It was log state function. It's pretty clear that we're going to be extracting multiple functions here, so we should have some sort of like function load Wasm function, and he's going to return whatever this thing is, wasmtime func t, and he's going to take in whatever the fuck this stuff needs. So we'll just, I guess, copy this and then figure it out from there. So he's going to take in some sort of like key, this is going to use the key pointer, and this is going to use the key length. And then we need this like item here. This is going to return a Boolean. And we need to pass in the WebAssembly context and the instance. So this is C wasmtime context T, an instance is a C wasmtime instance T. Boom. And then this becomes this needs to be failable. And then we need to return the thing. Yeah. Cool. So that means we can replace this with load wasm function using init, and the context is context, and the instance is instance. So I guess here, this instance should actually be a pointer like this, and then here we don't use the ampersand here. Then we can pass it in like this, chilling. And this is init func. So let's just start there. Init function. Then down here, instead of calling getString, we'll kind of just comment this out because we don't need it anymore. And instead we'll say function init. Fuck. Init something. Init chamber. Yeah. And this is going to turn us something. What does it return us? Some sort of state. So I guess, can we just call this like any opaque? We don't really care what it is, to be honest. Yeah, it's fine. And this is going to be, I wonder if we want to like factor this out in some way. We'll see. We'll see. Because like this stuff is consistent, this stuff is consistent, but this probably isn't. In fact, this chamber in it, we actually don't really care about it being a pointer. We're not actually trying to get a pointer to that thing. We're trying to get an offset that will be used as our like identifier in Wasm space. So I guess this just returns an I32. Yeah. And then we just call return result of I32. And then once we have that thing, we can say, hey, can we log the state given this state, which is just an I32? Yes. Yes. But we're getting ahead of ourselves. So here we can just say chamber mod is probably this. And then let's just call chamber mod init chamber. Let's just see what we get here. So chamber state is this. And then we log chamber state as an I32. We have some problems here. Root struct of C import doesn't have wasmtime. Fine. You don't have wasmtime, but you do have wasmtime, I assume. Nice. Expected error union type found I32. So because this guy has to say, not do I only return I32, I return an error or an I32. One of the two. Who fucking knows? Now we have initialization failure, which is coming from line 65. What's happening here? So he fails to find the init function because we are probably loading the wrong file. We are. We need to load. It's somewhere in the Zig cache. This. Fuck. How do I find this? We'll do this. Copy this. Hey, paste, zig, cache, objects this chamber wasm. Init failure still at line 45 now. So he's failing to load. He compiled the module fine, but instantiating it, he's not liking. Surprising. Surprising. Oh, probably because he's looking for that log wasm thing. So I bet you if we turn off this log wasm, maybe install the wasm to zig out. I should do that. But I'm gonna do later. It's not gonna end up there, but that's fine. Yeah, you're right. I should just do it. Fuck it. B install artifact chamber. You're right. So I think that if we do this, hopefully it'll still load. It's probably just failing because it's trying to find an imported function. He's going like, I don't have that imported function. Then in test zig, we need to, nope. What is our wasm chamber zig? Here we go. We need to change this to use the thing we just compiled. Let's try that. Okay, there we go. So now we get a number. Oddly consistent number, but maybe that's just kind of how the wasm allocator works. And now let's go back into chamber zig and figure out how to get this log wasm thing working. So this is going to, we need to zig build as well as zig run this now because we're recompiling the chamber. Okay, and now let's see if wasmtime has some examples on feeding it some shit. Maybe not. I don't see an obvious example there, but we can maybe look at the API that is failing, which is wasmtime instance new, and we can look at the documentation for this. So probably wasm.h. Nope, wasmtime.h. No? What the fuck? Oh, it's probably from one of these instance. There we go. So he has an extern t imports where we can say that we have a thing of this kind. So we're going to try to give it some sort of function here. And we have to link this thing probably back to a function in Zigland. Okay. So do they have like a func.h? We can create a function with this callback. Oh, it's super fucking easy. Okay, yeah, easy. So here we'll have our like function. Okay, let's just comment this out for a second. And the function that he wants is this callback t, I guess. Yeah. Here, okay. So here we should be able to say that we have some function. This is the return type. So he returns a wasm trap t. And this is going to be called like log wasm. He has some environment. Any opaque. He has a color. Just comes into the pointer. He has args, which are a pointer to constant c wasm time val t. Number of args, which is a size t, so u size. results is this. And the number of results is usize. Now we have to say that we want call conv c, I think. And I can't remember if this goes before or after the return type. I think before. Like this. No, he doesn't like that. Oh, maybe it's no dot in front of call conv. Here we go. Call conv c. And then we need to write c dot here. Okay. And here. And then can we just like panic here? I just want to see that like we can get this function called. You know? So on our imports, we now have to say that we have some sort of function. So we're going to here say see wasmtime func new given our context. And we have to give it a func type t. Where the fuck does that come from? An opaque object representing the type of a function. Oh, I see. So we need to like basically say how many arguments it has and stuff. So how do I make one of those? Bump, 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 bump. They import a C function to Wasm by index here. Nice. Nice. Thank you. Yeah, so they have this callback. And here they create a Wasm func type with inputs and outputs. So then they create the function and load it into this thing. Okay, and then they just put that in here. Nice, nice, nice. Okay, I was on the right track. This is promising. Promising, promising, promising. So here we'll just change this callback type. So we'll say const callback type is a C wasm func type new, and it's log wasm takes in two I32s and returns nothing. So is I32 like this? And yeah, I think that's fine. So here we have our func type t, which is callback type like this. Our callback here, which is just log wasm like this, I think. Our environment is null. Finalizer, do we need to have a finalizer? No. Null and log wasm func, we'll call it. Okay. Simple. This needs to be from cland. And then we need var log wasm func is a wasm func t, undefined, of course. Then they say that they have to delete the callback type. Func type, delete, callback type, okay. And this, I presume, can fail in some way. Wasm func new. No, this has no fail. Interesting. Interesting, interesting, interesting. So then we create our imports thing, and we just assign our function. It's just here. So var imports is an array of one of these. So we actually don't need to do this. We can just say var import is equal to c wasm extern t. Kind is equal to this. And of is equal to dot func is equal to callback func or something. Log wasm func. Why is everything orange? I must be missing a bracket somewhere. Something about this is just fucked. Because everything is not supposed to be orange, I'm pretty sure. But it'll become very clear very quick. When we try to use this thing and it's fucking broken. Okay, let's try that. End results, unused function parameter. Oh, it's actually like not that angry. Surprisingly. Okay. Line 48. This feels okay to me. Am I high? We'll see, we'll see. It'll get us there. $49. I added a line. Oh, I added a bunch of lines. So you're saying it's this thing, right? I actually don't see a problem with this, to be honest. Well, we'll just wait till it gets mad at me. Non-extern variable with opaque type. Really? How do they do it? This is wasm func t. Am I high? Wasmtime func t. Fuck. Wasm time func t. Okay, so now he's mad because he expected this thing and he found. Oh, do I have to put an ampersand in front of log wasm here? Maybe. No. Expected type. This should show. Found. This should show. Oh, I need to put question marks in front of all my pointer arguments because they're C. Calling convention, which might be null. Fine. Var import here at 56. Oh, so he doesn't just support struct initialization syntax, so I have to do like this. And then do import dot kind import of is equal to this, and then probably this is like this probably won't work either, to be honest. Non-extern variable with opaque type, so probably again here, this is supposed to be wasm time extern t. Where do they do their imports? Yeah, wasm time extern t. Yep. Oh, okay, so that runs. Maybe it is all supposed to be orange. It just feels like I'm not used to seeing this much more orange. Yeah, maybe it is. Okay, so this instantiated, and so now if we go in here and we try to maybe use this thing in some way, so we should have wait. Oh wait, if we call our log state function now, it should crash when we call log wasm in our chamber. So here we should just be able to do this same shit here. Except our log state function doesn't return anything. So we don't need this result type anymore. We can just write null and 0 here. And we just have to pass in the state in some way. So here we have our inputs now have to be used. So I think we have like wasm C, wasm time val t, I think is what it was called. And we just say var input is this. and then input dot do they have a function example here? Args kind is equal to c wasmtime I32, and we just then have to set input of I32 is equal to the state. Now we can pass in input here, as well as length of 1. And then we should be able to call log state, and we should be able to see something happen. Yeah. So here we call print, and then print calls log wasm, so we should see a panic if everything is right. But instead, we see no compile, because we did not put an exclamation point in the right spot. Okay, and then down here we have the right try here. Panic. Internal error. Fuck. 126. Interesting. Oh, because I called the wrong function. That would do it. That would do it. So here we just want to say log state function is log state, and we store it. And then up here we need to store it here. Let's try that. There we go. We panicked. Very good sign. So we called back into Zig from our module, which is very good. And then we should just be able to do something like std debug print this string. And the string is going to come from, we're going to look at the memory from somewhere, which I don't know if we have access to here. Sorry, one sec. My nose is really itchy. Fuck. Okay. So this environment type, I don't know how we get the memory out of it. Because this is going to have a pointer and a length. So we need memory. Is it in wasmtime caller? What is a wasmtime caller T? Alias to wasmtime caller. The purpose of this structure is to acquire a wasmtime context pointer to interact with objects, which can also be used to inspect the state of the caller. So we should be able to pull memory out of this somehow. But what we can do instead is we can just pass in our memory as the environment pointer. So I think it's func call he has where does the environment come from? I thought there was one. Oh, maybe it was when we bound the function. Maybe it was when we bound the function. Here. Wasmtime func new. We can pass in a void star, which we can probably point to the memory. Let's do this. So when we get the memory, let's let's make it a pointer so that it has a stable memory location. Which means that we have an allocator. So memory here can just be memory equals item of memory, which happens here. Oh, well, this happens after the fucking binding of the function, but we could do a const memory up here is a pointer to c wasmtime memory 2, I think. Is that right? Yeah. And this is going to be some sort of like try alloc.create c wasmtime memory t. Okay, then we can feed in this pointer into wasmtime func new, which is the first null. Then when we try to do this, we say our memory dot star is equal to item of memory, and we just have to look at other places where we use this now. Self memory. It's not used anywhere, so it's actually fine. And then up here, we can say our memory is a pointer to see wasmtime memory t is equal to env. Yes. Yes. And then we can do this, where we pull the memory out of this thing. We don't have context. Oh no, where's the context come from? The context I think that we should be able to get from wasmtime caller t. Pretty sure I saw that somewhere. You can maybe alloc the chamber on the heap and then pass a bunch of it. Yeah, I was considering that, but I think that we can do this instead. I will fall back on that if I have to, but I think we can do this. Wasmtime caller context is from caller. And then here we should be able to pass in context and memory. Okay. Then we should be able to print. We can look at our args0, and our args0 should have of I32, and our args1 should be the length, and we should be able to look at p from offset to offset plus len, but these have to be cast to usize for this to work. So this comes from p offs plus len. Okay. This is like maybe functional. Zig run. Pointer cast, so we need to align cast as well. Fuck off. But I get it. And then these args need to be, like, I am certain that they are not null. Still no, actually. Because these guys this needs to be multiple element pointer. And then we need to return null. What does line cast do? Okay, so if you have like, you know, var x is equal to I32. Or if you were to do var x is equal to alloc create I32, right? Because of the way that like your system is designed, this x has to be at a 4-byte offset. So Zig, when it gets in this pointer for environment, he doesn't know who allocated him, so it might not be at a 4-byte alignment. And so this align cast says, hey, this thing needs to be a fucking pointer of 4, or a multiple of 4, basically. If I understand it correctly, which I might not. Oh! Oh, hell yeah! Oh, fuck yes. So the log is working. It's fucking working. Look at that. That's so fucking sick, man. That's sick. So we have allocated this chamber state, which comes back with an I32, which is a pointer into WebAssembly memory from the module. We say, hey, WebAssembly, could you log what you see in that thing? Then in Zigland in our WebAssembly module, we call our print function, which basically formats our structure according to like Zig formatting rules, but then calls this like log wasm function with the string, pointer and length. And then in our log wasm function, we like extract that pointer and length back out, go back into WebAssembly memory, pull the string out, and then print that. And that fucking shows up right here. Dude, that's so sick. That's sick. Okay, so we have calling into wasm from Zig, calling into Zig from wasm. And that's fucking sick. That's super sick. We are 2 hours in, so I think that's a natural kind of ending point. We have kind of like the basics of a chamber. All that's left to do here is to kind of like stub out the rest of the functions that we want to call. So we want to call this like step function. We want to, is that maybe the only thing we want? Yeah, that's kind of the only thing we need to add now is our ability to call step. And D in it probably. But yeah, that's pretty cool. Pretty cool. But we'll come back to that tomorrow, I think. Tomorrow, I think, is fair. So, thanks for watching, guys. If you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. Right now, we're working on this, what is it called? Rube Goldberg machine that is based off of Wasm modules, but there's other stuff on YouTube if you want to go check that out. So we have all of our previous projects organized into playlists, as well as GitHub link in the Twitch description, which has the code for all of those projects. If you're watching on YouTube, there should be a Twitch link in the YouTube description. Swing by and say hi if you're online between 2 and 4 o'clock Pacific time, if you feel like it. Like, subscribe, Twitch Prime, and I think that's all we have to plug. YouTube, see you later, and Twitch, let's figure out who to raid.